a webinar on the topic of artificial intelligence and application and its introduction. So it is jointly organized with our team, twinning partner, DVM Engineering College, Anand, and the organized with association with Rebel Nazarbayev University, Kazakhstan. So in the second section, it's our pleasure that we have Dr. Samir Sharma from Photo Group. So I just want to briefly introduction them. Dr. Samir Sharma, welcome you.
Thank you so much for having me here.
Okay, thank you. So I just want to briefly introduce about Dr. Samir Sharma. So he is currently working as a head R&D in the Photo Group. So Mr. Samir done his PhD from IIT Madras, and he is achieving IIT Madras in the industry and production design, and bachelor degree in mechanical engineering from the Thapar University, a master degree in Thapar University. He was awarded a gold medal for his master dissertation and the Gandhi Young Technical Innovation Award by the President of India. Sir, it is our pleasure to have with us. And prior he joined the Photo Group, Samir has held engineering position at LG and International Tractor. So it is very pleasure to have with us Dr. Samir. So now I hand over the session to Dr. Samir. Then please continue the second session. Dr. Samir.
Thank you so much. A very good afternoon, everybody. First of all, I have two disclaimers. So my company is called Photo Gauge, and I don't work for production design. I work in the research and development branch of the company. I also know that I am probably the most hated guy in the room right now because I am between you and your lunch, or probably you and your afternoon nap. So what I'll do is I'll try to keep this session succinct and to the point, and also give you a high-level overview of what AI is. Right now, everybody wants to learn AI. People are there who claim that they can make you AI experts in 70 hours, 50 hours, as if this is a weight loss challenge. So all I'm trying to do here is to fuel the curiosity into young minds who are joining us from different parts of the globe, I'm assuming that. So before we get started, so I would like to thank the respected faculty members, the organizing committee, my dear friends at Banswara College, and my dear friends. AI is a disruption which people have different claims about. This is again a challenging time where humanity has been pushed to a wall by a natural calamity. And it is not the first time that we have been pushed to a wall. As humanity, we have suffered calamity, natural or coming out from the disputes within. And we have always stood our tasks. So AI is not a force. The first thing I would like to chuck away from your mind is AI is not something of a magical tool. AI is not going to take over the world. Let's be open-minded. Let's try to understand and appreciate what AI has been doing, how it has been disrupting and making our lives better. So my session is focused on the positive and real aspects and practical aspects of AI. I come from a mechanical industry. Our clients are in US and Europe. All these clients, they are manufacturing industries. In fact, I am a mechanical engineer. So my applications that I'm going to present today will also be focusing and catering to only the mechanical industries. How people are using this so-called magical tool of AI and really changing the landscape of applications in mechanical industry. So the way I have envisioned this session is I'm going to give you a high-level knowledge. I'm not going to cover the breadth and the depth of this beautiful technology. All I'm going to do is throw some keywords for you to go back and look. Throw some keywords at you to debunk what are the myths surrounding AI and to really fuel the fire in your minds about AI and how you can incorporate AI into your fields. So are we good to go? Can you please show me a thumbs up if you're excited to go ahead? Okay, so let's get started. Let me just share my screen. It's complicated.
Yeah.
Okay, let me just try it. There you go. Can you see my screen now?
Yes, sir.
Okay, excellent.
Yes, sir.
Super. Okay, let me get started. How many of you have seen this video? So today, let's first try to see and appreciate where is AI being used and what are the different applications, and in fact, mind-boggling and intriguing applications of AI. So one such example is really the Atlas robot. How many of you have seen this video? I want you to see this 40 seconds of the video. A robot hop jumping, twisting, showing us some dance moves. Some form from Parker movement, and does a backflip. Last time I tried, I almost broke my neck. But look at it. It is a clean black backflip. So now I would like to ask a question to all of you. What do you think would entail if you are trying to do such a backflip? Has anybody of you tried a backflip before? I think if you guys can give me a few answers, it'll help me. It is not live. I just want to make it a little interactive. So imagine.
Not yet, sir.
Oh, not yet. In fact, I tried it. Like I said, I almost broke my back. So now the thing is that look at what the AI is doing here. The robot is not only able to balance itself. It is moving. There are objects in front of it. It knows that these objects are not the ones where you run into them directly, but these are the objects that it has to avoid. So it is jumping on these. Once it does the backflip, it does all the physics computations that are there and balance itself on the ground. How amazing this is. So this is AI for you. Another example. If you think AI is only done for robots, my dear friends, look at this video. So this is a video by DeepMind, which is an entity of Google now. And what they did was they trained an AI which learned how to walk by itself. Look at us. It took us millions of years of evolution and hit and trials, and then we started to walk. And this AI, given set of rules that it was not supposed to fall, it was able to do that. Another thing that the scientists at DeepMind found out was really it was avoiding the obstacles as well. Look at every obstacle, it makes an error, and this is again it is a funky style of really running, but the beauty here is it has learned how to walk, how to leap through the obstacles, how not to fall into the ditches, and how to avoid the obstacles. Look at it. It may not be human-like. These motor skills that we have accumulated over years. We are able to walk, we are able to jump, we are able to really lie down, the way we drop, it's all human-like. These motor skills that you see on the screen may not be human-like. But the idea here is, look at how far we have come. Look how much time it took us for us to be able to learn and walk. But the AI, it is doing the simulation. It is trying to learn, and this is fascinating to me. Now you may ask where it can be used. So this is another way to show that if simulation can help a robot or a simulator to attain these motor skills, what it can do. By the way, this is the same model this is the same team which actually developed AlphaGo. I'll go into that later, but this is the beauty of it. And don't you think it is dancing? Because it is trying to balance itself given the physics and the physiological behavior. So this is, my dear friends, AI for you. Are you guys with me right till this point?
Yes, sir.
Okay, great. So we saw that how AI is enabling a robot to take a backflip. We saw how AI is enabling researchers to figure out what are the motor functions and probably help develop a biomechanical system. Now, where did it all start? Where did the AI started to make the front page of news? It was in 1997. Deep Blue. It was a program which was developed by IBM Research, and it was the first time in the history of chess that it defeated a world chess champion that time, the great Garry Kasparov. Now the thing was that if you look at, have you all played a game of chess? It is Indian, bhai. Please try to play a game of chess. So now in chess, you have 8 cross 8 squares. So there are 64 such squares. And then based on everything that you have in chess, there are 10 for 120 configurations that are possible. And Deep Blue somehow learned all these configurations, and not only just learned in a way that it was able to play a game, but it had learned in its own dynamic way, where it was able to defeat the world champion. 18 years later, 2015, AlphaGo. How many of you know what Go is? Okay, again, I can't really see your faces, but Go is really a form of board game, which is the world's most famous board game played in China, South Korea. Now the thing is that look at the number of configurations that are there, 10 to the power 174. It looks like, oh, 10 to the power 120 in chess and 174 in Go. It is not a huge deal, but it is 100 million trillion times more configuration than Deep Blue. And then there was a world champion who is considered to be the greatest, Lee Sedol. So this AI system actually defeated the world champion 4-1 in a 5K. Now 2 years down the line, 2017, the same team published AlphaGo 0. This was again even more powerful than AlphaGo. So much so that in first 100 games, it defeated AlphaGo 100-0. And then came Google in 2017, around November or December. It actually developed Alpha 0. So Alpha 0 can play Go, can play chess, and it can defeat anybody in the world. So the beauty here is really not, it is noteworthy to note that all these AI systems were able to play and in fact defeat the world champions. But the beauty is in the simplicity. None of the developers or the programmers who developed these AI systems, the entire teams, they were experts in Go. But what they were able to do was something which fascinated the entire world of board games. And this is, my dear friends, AI for you. Now, if you're imagining, if I'm sitting in a room, oh, people are developing robots, people are defeating the world champions, but how is it related to me? Okay, if that is the case, let me go to my YouTube page. Can you see it? How does YouTube know what are the videos to recommend to me? How does it know? It is recommending me videos. Yeah, if I go to my Amazon, I was looking at my Amazon. How does Amazon know? Why is it recommending these systems to me? And I am just one of the hundreds of millions of users that are out there. Does that mean Amazon has assigned a person who looks at what I'm what videos I'm watching, and then it actually goes through hundreds of other videos and then probably pick a best video for me? Do you think that is happening here? Can you just tell me yes, no, or maybe? Okay. Can you just, anybody of you, if you can tell me, what do you think is happening here? How is it able to recommend, and that too not only to me, but to the millions of other users that are out there? The same thing is true with online. Now, if you guys look young, if you're planning to marry, there is Bharat matrimony. Now, how does it know what is the best match for me? How does all these things know? There are millions of users and it becomes so hard. So you're right, there is an AI system which sits under the hood.
They try to match the interest, I think.
But you can say, how do you quantify an interest? How do you even quantify what my interests are just based on the videos I'm going through? Suppose I just go through all the AI videos, or I'm interested in buying a Tesla. That I understand. But then it is much more than that. If you look at my recommendation, somehow it is recommending me to look at some espresso, a famous actor doing push-ups. There are videos which I watch online. So how does it do it? How does it quantify it? So this is the beauty, right? What I'm trying to say, that these systems have an ability to learn from their own experiences without being explicitly programmed. There is nobody sitting there programming only for Samir Sharma or only for Akash Deep. There are systems which are learning and then giving out output. And this is AI, my dear friends, for you. Okay, you got it now? So we have seen 4 major applications of AI. One, AI is sitting right into your laptop, into your personal space. You have YouTube, Facebook. Facebook gives you an idea of people you may know or friend request recommendation. How does it do it? Where is the interest in that? Are you interested in their white shirt because you search for white shirt people? How does it all work? Or like I said, Bharat Matrimony. How do you even know which is a good match? Or YouTube or Netflix. You watch some videos. So are you trying to say that the AI has seen all the movies that I watched and it has understood the sentiments behind those movies, and now it is recommending me a movie based on the kind of movies I saw? So this is the beauty. I would like all of you to appreciate this fact. And again, let me reiterate what I reiterated the first time. That when you saw developers developing Alpha Zero or Alpha Go, which actually defeated the world champions, none of those developers were world champions. None of those developers, in fact, some of them, they had not played Go before starting programming. So there is an interesting aspect to it, which suggests to me that if you start to learn AI, and like Andrew Ng, who is probably the most influential person in AI right now, he says AI is the new electricity. So if you know this skill, really you can go to any field. People have started to use AI into biomechanics, trying to understand if there is a lung cancer, there is a tumor in the lung, if it is benign or malignant. There are people who have started to use AI to develop driverless cars. Now imagine if you're trying to develop a driverless cars, forget about India, because India, you can have anything and everything on the road, from a meteorite, from an alien to a cow or a human or a drunk person. But imagine a place where people follow traffic rules, but still there are so many variables out there. How do you even define what is a person, what is a cat, and a flying polythene? How does the car learn that now it is the time to it is okay to go at the same speed when there is a polythene which is hovering in the air, and not okay because there is a human, there is a cat or a dog in front of it? People have started to use AI into mechanical industry, trying to understand what is the material structure. People have started to use AI to do COVID research, trying to understand which strain of this virus is and what are the different salts and medicines that are out there, which you can, and try to see what is the fidelity of each of these medicines. So there is this plethora of application. This entire envelope is getting bigger and bigger every day, because young people like you, people who think that this is a tool which, like electricity, this is something that this is more general and I can use it in my field. This was necessary, my dear friends, to give such a long monologue for AI, because I would like all of you to get excited, all of you to appreciate what AI is doing, and all of you to start thinking and hashing out plans on where can I use AI in my field. Are we good to go?
Yes, sir.
Okay, great. Thank you. Yeah, so this is AI now. Now the thing is that once you start, now let's talk about people, let's take care of the interest of people who would like to dabble into AI, machine learning, deep learning. Where do you start? You go online, you see thousands of people, thousands of websites claiming that they can teach you AI, they can take you from being a zero to a hero. Before you do that, don't you think it is better to understand what is AI? What is ML, as in machine learning? What is deep learning, DL? And how is it connected to data science? Are all of these things same because people use it interchangeably, or is there a difference? And ladies and gentlemen, there are subtle differences that you need to be aware of. Yeah. So before you do that, let's understand what are the types of AI that are out there. Again, a very high level knowledge. So there are three kinds of AI. First one is artificial narrow intelligence, which is also called artificial weak intelligence. So this kind of system is what you see in the entire world right now. So these systems are basically developed to perform a specific task. For example, we are humans, right? As a human, I can ride bicycle, I can drive a car, I can learn new skills, I can cook food, I can jump, I can exercise, I can run faster, I can sleep, I can wake up. You see how, as human, we do all these general tasks, without thinking too much about it, without appreciating our motor skills. Yeah. But the AI that you see, the robot that you saw, I don't think that will be the robot doing a backflip. It may be better at doing backflip. It may be better at doing balancing. It is better at dynamics, but it can't drive a car. It can't make food for my wife. It can't do the dishes. It can't learn a new skill. The humans can. Another driverless car. A driverless car can go around, but it can't do a backflip. Or an AI which learned how to walk, but it will take it some time before it start to do how to cook. You got my point, right? So all these AI systems that you see in the world right now, Netflix, take YouTube, all these systems are doing a specific task. And these machines and systems are as good as the data that was being used. There was a recent furor on Twitter where people were blaming one particular model as being racist because it was predicting a human of a particular color of a skin better than the other. Or for example, you are trying to say that given a photograph of a part, if it is defective or not, right? So a model can only learn if it is defective or not. An AI system can't do everything. There is no general intelligence here. So when people say AI, they are often in this world, they are talking about weak AI. It is narrow artificial intelligence. Yeah. Now let's talk about the second type is called artificial general intelligence that you see in movies, sci-fi movies, the good robots like Wall-E or Chitty, robots which tend to exhibit sentiments like humans. They tend to exhibit human-like behavior. They feel sorrow. They feel happy. So, but none of these things is there in anywhere in the entire world. There are, as far as I know, because as far as my domain of work takes me, there are no general intelligence robots out there. And then the final is artificial super intelligence, which is the Terminator, who are going to come on Earth and really, it is when artificial super intelligence start to claim stake on planet Earth is when we have to book a ticket on Elon Musk spaceships and go and settle on Mars, because that is far away in future, and I don't think none of us in our lifetimes will ever be able to see general intelligence. Forget about super intelligence. Yeah. So now, are we clear? When we say artificial intelligence, we are talking about narrow or weak artificial intelligence. Yeah. Say yes or no, please.
Yes, sir.
Great.
Yes, sir.
So now we are clear on what AI is. Let's talk about, people say machine learning and deep learning. My dear friends, machine learning and deep learning are a small subset of AI. A robot that you saw doing backflipping, that robot has an array of sensors, an assortment of hardware and software. It has sensors which would help it balance. It has gyroscopes which would help it do those backflipping and maneuvers, right? And all these sensors are feeding data to its brain, and probably that's where machine learning comes in. So machine learning is nothing. It is an AI. We can say that, right? Because it is a subset of AI. So machine learning, it is a group of statistical techniques that have an ability to learn by their own experience without being programmed explicitly. So can you tell me now, if YouTube, Netflix, and say all the other recommendation system that I talk about, or in fact the robot, what do you think? It is an AI or specifically ML? Which one of it runs on purely ML? Anyone? It's okay. I can see.
Recommendations are made by machine learning, I think.
Yes.
Because these are a set of rules, as you told, the algorithms.
Yes, beautiful. Thank you. Sorry, I would not be able to say your name because I am not able to see the screen, but it's okay. Yeah, thank you so much. Yeah, absolutely right. It is ML system. These are ML systems. So basically these systems have been trained to do that specific task or recommended you. Like one of the attendees, he rightly pointed out that probably based on the interest. So these are the set of rules that it actually, these are not quantified rules. These are some lower level rules that it defines to recommend your video, or when you Google search it, so it tells you which is the most relevant page in a second. So all those are machine learning systems. Now then what is this yellow box? Deep learning. So again, somebody says deep learning. Of course, it is also an AI, like machine learning, but deep learning is a specific type of machine learning technique where we use neural networks. Hence the word deep. And neural networks, why do we say deep? Because look at our brains. We have general intelligence. We can do many tasks because our brain is so complicated. It is in fact next to impossible to approximate such a complicated system. So those techniques which use neural networks are deep learning techniques. Yeah. So now if somebody tells you they'll make you expert in deep learning, you must ask them, sir, are you talking about, do you even know what deep learning is? Are you talking about the machine learning techniques which use neural networks? So in that case, don't you think I should learn machine learning first and then only I should go towards neural networks? Yeah. So this is the kind of awareness I wanted to bring to this slide. Are we clear?
Yes, sir.
Beautiful. And where is our old friend data science? So data science has been there for centuries now. So data science is really a field which assists AI. So data science is about what? Data science is all about data, as the name suggests. No prize for guessing there. So what it does is, given the data, it summarizes the data, right? Using techniques like exploratory data analysis, you can not only just summarize the data, you can analyze the data by visualizing what are the different patterns that you see. Suppose there are COVID cases going on, suppose in my home state, Haryana. So what happens is, you will try to get data from the state health department, and then you can visualize what are the different clusters based on the regions. Are there specific regions where these number of COVID cases are more? Or is there a different correlation? Is that so that males are more susceptible to get infected by COVID than females? Yeah. So all these things you can do with data. Now, this data is also important for machine learning. Yeah, because machine learning and AIs, we are training using data. So that's where we use a portion of our techniques whenever it comes to pre-processing the data, processing the data to be able such that we can use it for training these deep learning and machine learning models is actually the portions of data science that we use. Okay, so at this slide, I conclude that basically when somebody says AI, DL, ML, data science, they have to be mindful of that these four terms are actually, they carry different meanings. And it is always good to understand the nuances before we get into details. It doesn't hurt, right? Now we know what are these four terms meant. If anybody of you have any question, I can take up or else I'll go next. Or we can take the question at the last. Yeah? Okay. So again, this slide is, like I said before, I'm not going to cover the breadth or even the depth of machine learning, but some of the keywords that you would have heard, I am just jotting them down for you to see. So ML, you have linear regression. So there you are supervising the data. Likewise, it does it for millions of users that are out there. And just keeps on learning, okay, what are the interests, and based on that, it's a system. Now, unsupervised learning. Unsupervised learning is basically trying to understand the correlation, like I said, the correlation, it is mostly using data analysis, right? So you want to understand what are the correlations, what are the different correlations. I'll cover some examples there. And reinforced learning is really something which is close to, suppose, general intelligence. If something is going to be a general intelligence or an AI with general intelligence, it is going to be from reinforced learning, because reinforced learning is like teaching a kid. Suppose you have a kid and you are excuse me, you are trying to teach the kid how to write. Yeah. Now what you can do, give me a second. Now what you can do, that you can define rewards and penalties. Okay, if the kid is able to write the letter that you're saying, suppose letter 2, then you give a reward, probably a piece of chocolate. And if not, then you give a penalty, right? So this reward penalty, there is an agent, which is a kid in this case, and then you give this reward and penalty, and the model learns better and better. Yeah. So probably in the recommended system that you see on YouTube, it is also using reinforcement learning, because reinforced learning is, as you have deployed a model, it is learning throughout its lifetime based on the examples. It keeps correcting itself. Yeah. So for example, YouTube suggested a recommended video to me. Yeah, I did not click on that. So that's a very good information for the machine learning model, that whatever I did, it was not correct. So the machine learning model gets penalized. Yeah, and every time I click on a video that's recommended by the system, that is a good sign for the machine learning model. So it knows how to retain and use that as a reward. And that's how you keep, can you please turn off? I don't know, you may have to mute yourself, guys. Somebody is unmuted. Mr. Organizer, can you hear my voice?
Yes, sir. Please go ahead. Yes, sir. Please go ahead.
Yeah, no, somebody had his mic.
Sorry for that. Please
I would request, please keep your mics on mute. Okay. Yeah. So you got my point, right? So this is what reinforcement learning is all. Yeah. So now machine learning is out of the way, because I'm going to talk about deep learning, because deep learning is based on neural networks, which is probably in a nascent and early stages of being used in mechanical industry, but it will be interesting to see what are the applications. Okay. Before we go into the applications, one thing I would like to cement in your heads is something: what is the key difference between the conventional approaches, rule-based approaches, and machine learning? Yeah. All of you can see my screen. So suppose there is a rule-based engine. Yeah. So what you are doing is, there are two inputs to this engine: x is equal to 2, variable x, which has been assigned 2, and y is basically a function of x, a quadratic function, right? So you run through it, and then the output is basically y is equal to 31. Any middle grade schooler would know this. Yeah. So these are called rule-based systems, where you have defined a rule. So if there is a variable 2, and if you see a x square, then 2 has to be multiplied 2 times, and then multiplied with the respective coefficient, which is 3 in this case. Yeah. All these rules we have already defined using mathematics, and all you have to do is take that input, put it in the rules, and get the output. Yeah. Do you think that is possible? So all what you are trying to say is, suppose we are developing a driverless car. All we have to do is basically take stock of all the possible variabilities and define them as rules. Meaning, okay, if you are in US, drive to the right, try to follow the signboard. If there is a turn, take right. If there is a tree which has fallen between the street, hit stop. If there is a crash that is going to happen, change lanes. All these rules, if you could define, then you can still solve problems, right? You really don't need machine learning. Where is the learning component in? Can anybody tell me why am I saying that? What do you think? So all I'm saying is, probably it is, if I am able to define the rules, I don't have to do machine learning like I showed in previous slide. There is no machine learning to it. All you are saying is, given an input and set of rules, you can compute output. So likewise, I'm saying, give me a second, let me play this nice video. Come on AI, I'm appreciating you. Okay, so now all I want you guys to do is basically look at this video and tell me, why do you need machine learning if you can define certain rules? So for example, okay, there is something left that you have to take, but look at the complication here. There's a car, you have to stop. There is a green light, it has to take left. Look at the speed now. Keep an eye on the speedometer and odometer. See, it is going at 75 miles, which is 75 into 1.6 kilometer per hour, probably over 100 kilometers per hour. How does it know? Look at the kind of decision the AI system is making right now. The cars which are going at 100 kilometers per hour, the human, the backup driver is doing nothing. Did you see there was a car on the right which was standing right next to the road? How did it know that it has to avoid it? How does it know it's this complicated grid of roads that it has to follow? All the driver did was entered where it has to go, enter the destination, and there was a map, and it is just following the map. If that was the case, then where is the machine learning component to it? If you have to go from point A to point B, because once you start going there are so many things you have to keep your mind on. What if there is a construction going on? What if suddenly it starts to rain? What if the visibility is not great? What if somebody is doing rash driving? You are following lane. What if somebody is not following lane? Yeah. What if there is an accident in front of you? All of a sudden, somebody lost control of his vehicle. All these things. Imagine the kind of decisions that you make while driving a car. Now, all those decisions and rules you'll have to define for such a driverless car, isn't it? Can you tell me if yes or no?
Yes, sir.
All my point was to show you that this is what is being done using AI. That AI, if you are going by the route of defining the rules, it just becomes out of hand. In some point, it becomes next to impossible. But if you have machine learning systems, they help you define those rules. So what is machine learning? Look at my screen now. In machine learning, what we do is we take the question, which is x is equal to 2. We also give it the answer that y is equal to 31. Sorry, in this case, in the top one, it is y is equal to 31. So it says y is equal to 31. So then the machine learning, basically, it identifies what is the rule, right? Now, given enough data, so there are multiple options that are possible. Can you see on the screen to the right? I can still get 31 by an x is equal to 2 by different equations. Yeah?
Reverse process.
So what it does is, it actually learns rules for you. And how is it important then, you may ask? Importance is, next time when I have a value for which I don't have an answer, I can use these rules and define those answers. So what they do is, for the driverless cars, they really train the systems. They go through every possible variability that can be there on the roads. And then actually you can, next time there is a new possibility that comes in front of their eyes, they really know what rules to follow. And if that variability, for example, you are an Indian road and suddenly there is no road at all, so it knows where to stop. So the map is showing a beautiful road constructed, and really you go there and there is no road at all. So in that case also it knows what to do, because these are the conditions it has never seen, but it knows at least how to do that. It would stop. So this is what machine learning is, ladies and gentlemen. Machine learning is trying to define those rules for you. For example, I'm watching YouTube videos. It has questions they are suggesting new videos to me. And then really rules are, probably Samir likes AI, he likes watching, listening to old Hindi music, he likes listening to videos with these tags. Yeah, so it defines rules. So next time I watch a new video, it knows based on the rules, okay, probably this is the video we should recommend to someone. Yeah, so this is the clear-cut difference between the conventional rule-based approach, where we used to define our own network, like what you do in computer. You could put 2 plus 2, it's always 4. And why? The rule is being learned by the machine learning model. Yeah. Okay. Are we to go?
Sorry to interrupt you, Samir. We cannot able to view your presentation.
Is that so? Okay, let me try it again. And when did that happen? Don't tell me I was telling my life story and it was happening from the start. Are you able to see that?
Just before a couple of minutes, I think 1 minute. Yes.
Are you able to see my screen?
Yeah, we can see.
Great. Okay, thank God.
Thank you.
Yeah. So this was machine learning, guys, for you. So now the thing is that I would like to bring in some complications that are there. And why do you need machine learning, right? Like I was telling you, there is a driverless car, and in front of driverless cars, there is a cat or a dog or a human or an object or a piece of hay or a haystack. How do you know? So what happens is, look at what you see. Now, if I give you this example, give you this photograph, everybody of you, I'm sure, will be able to predict which one is a cat and which one is a dog. We can do it, right? Okay? But the thing is that, but why is it so hard for the computer to learn it? I'll show you how. Let me just show you a real example. Do you see a nice dog here? Sir, please tell me if my video is visible because I'm going to swap between and toggle between various videos.
Yeah, visible.
Okay, great. So for example, given this the photograph of a cute dog, now what you're asking is, so this is photograph probably the driverless car ka camera sees. Suppose that camera sees it and it would like to make a decision. See, this is, if you are able to identify between cat and a dog, then it really becomes just a this is a question of how do you define the problem, and you can identify different aspects of it. Then why just cat and dog? You can define if the part is defective or not, given a photograph. If there is a human which is standing or it's in other posture, all these things you can do, right? You can define if there is a stop sign, if that stop sign says, or if given a light, if it is green, I have to go. Right, all these identification and classification tasks you can do. So that's why it is easy for us to understand from the basic classification problem. So given a photograph, can you identify what is there? Is it a cat or a dog or a human? Now for us, of course, we can say, Samir, you've lost your mind. It's lunchtime and probably it's time to go nap. But the thing is that for computer, it is not the case. Computer sees this not as a dog, but I'll show you. Okay, so if I do this, so I say define this image. What I'm trying to do is trying to read this image. Tell me if you're not able to see my screen, because this is important for you guys to see how we code and how things go. Okay. So now if I plot it, say it's in show. Yeah. So the computer, even though for us visually it looks like it is a dog, right? But look at this, what computer sees it like this. For computer, it is just a bunch of numbers. Nothing else. Look at the entire, in fact, I can plot it here. I can look at this. A bunch of numbers. Now given a human, it is again going to be a bunch of numbers. And what are these numbers? Basically, this is the intensity of light falling to that particular pixel in your image. So that's why it becomes so hard, and it has been a hard problem for many, many decades now. It was until probably early 2000, mid 2000, when early 2005 or 2006, when ImageNet Challenge was posted. And then there was a network called AlexaNet, where they used machine learning tool to identify if it is a cat or a dog with close to 99 or 98% accuracy. That was a huge jump. Earlier, people were defining rules. Okay, if the snorkel is certain shape, if there are certain features which look like dog-like, that's how people used to define rules. Like we were discussing for the driverless cars, that if you are to define rules, you will run out of options because there is so many complications. So now there is a dog. What if there is a background, there is a dog? What if there are dog breeds which look similar to cat breeds? How does it? So all these complications and machine learning really comes to rescue, because machine learning learned the lower representation, the underlying representation of what a dog looks like. For example, this is just, I'll show you this. This is really intriguing to me. So what it does is, it has this neural network, like I told you. I'm not going into detail on say what are convolutional neural networks, what are artificial neural networks, or what are recurring neural networks. I'm not going to go there because that you can there are resources. I don't want to confuse you. But the key idea is given a cat, like a machine learning model which actually it generated a mathematical representation of my recommendations of the videos, of my interest of the videos. Likewise, given a cat, it never looks at just the eyes of a cat or certain features of its texture or contrast of its skin. But what it does is it learns something abstract. In fact, people and researchers are trying to understand what is it learning. It's an open area of field. It learns it. So next time you give an image, look at this beauty here. And the right two are actually the outputs of certain layers of the model. This is beautiful. The output representation of these models. So now the thing is that look at what is going on. So a cat is being taken as look at this. This doesn't look like a human at all. This doesn't look like that humans would represent a cat in this way. Probably we have learned over time that a cat looks bit cranky all the time. It has this nice whiskers. That's about it. But look at mathematical representation of a model which is learning, and this is something which people are able to do now, and all of you can do it. The two things are actually the output of middle layers. So here, if it's a neural network, in the most form of basic neural network has an input layer. So input layer is basically what are the pixels. So your image is actually the input layer. Yeah. Then there are hidden layers. You may have one, or in some cases you may have hundreds of these layers. And then an output layer which actually suggests if it is a cat or a dog, right? So these outputs that you see, the rightmost is the last but one layer, what it is learned, right? And then the middle one is somewhere in middle of the hidden layer, just trying to show you what representation of a cat it has learned. Yeah? Are you guys with me right now?
Yes, sir.
Yes, sir.
Okay, great. Okay, now,
Excuse me, sir.
yeah.
Excuse me, sir. So how do we define it's cat or dog? Because it's only based on intensities, right, on which it is perceiving the image. So how does it know it's cat or a dog? It's just an image.
Yes.
So I don't understand that.
Okay, yeah, that's so I think you have given me a small win right there, because this is the curiosity I wanted to bring in. So what happens is, for you it's a cat and dog. For a computer it is just bunch of numbers. But how do you define a cat as human? You look at it, right? You have seen many cats in your lifetime. People have told you this is a cat and this is a tiger, right? People have told you what kind of dogs are there. People have shown you your family members have shown you what kind of different cats are there. You have seen on videos, right? You have a mental representation of a cat, isn't it? Just say yes or no.
Yes, sir.
Yeah. Now, for a computer, that representation is called a mathematical representation. So what it does is, like you have somewhere, every time you see a cat, so what happens is certain neurons in your brain, they fire, and then they tell you based on the data that is coming from your eyes, right? And probably your ears, you're hearing the meow of a cat. So for example, if the cat is silent, you're just looking at the cat, and then suddenly your brain says that this is a cat, right? So meaning you already have a representation. Your model is already learned. You have already learned. Likewise, for a mathematical model like machine learning model, it just learns that low level representation of a cat. So what we do is we give millions of images of a cat, yeah, and every time we give or we supply to the model, we always label it as the cat. So the model, with every example, it is learning some representation of what a cat looks like, right? With every new example, with every new color or a breed of a cat, with every new angle with which the cat was shot, right? With every new move the cat was making in an image, all these things, or the entire ensemble, it just learns mathematically, and that is the representation I'm showing you on the screen. This is what on the right hand side a model has seen. Now, given a new image, like you said, so you give a new cat image which doesn't look like this cat image, which looks like this cute kitten image. Yeah. Now what happens is the image still goes through the neural network. It still goes through all these different layers. And for each of these layers, the layers would see if it conforms to the representation that it has learned, which is in terms of biases and weights, for example. Yeah. And then at the end of it, all these machine learning models, right, they always yield results with a given probability. It will always say that model would give you an output that this is a cat, but with probably a 98% probability, which is something called a softmax score. Yeah. So to a short answer to your question is basically like we have learned representations, even though when you are a kid, probably you're 2 or 3 months old, you would not know what a cat is. So you have, over years, you have learned the representation of a cat. Likewise, a model for which initially when you give an image, it just looks like a bunch of numbers, but given enough training examples of cat, it learns the representation like you have done. That's why we talk about deep learning, right? Deep learning tries to mimic how humans learn via neural networks. That makes sense?
Yes, so it keeps on updating itself, right?
Yes, it keeps on updating. Beautiful, right? This updating is something called, there are something called weights and biases. You may go back and look. I'll point you to some resources as well. So those biases and update biases, those biases and weights keep on getting updated with every example that you give.
Okay, sir.
Yeah. Okay. Thank you. So these are some of the tasks which now at current movement in 2020 June people are able to do without much error. So what happens is these are some of the terms, again keywords. I was not sure whether to include this slide because it's okay, but these are some of the keywords that you should know. Semantic segmentation, given an image, what every pixel belongs to. On the left you can see. So every pixel, okay, this entire thing is grass. The entire magenta thing or the purple thing is actually this bunch of forest. This is a forest and bunch of trees are seen. Then blue is actually sky, and then this is entire cat. This is called semantic segmentation. Then you have classification and localization. And why is it important? Because when you are developing driverless cars, you would like to do this kind of segmentation, isn't it? Because you would like to make sure which is road, where are the lanes, where are the other cars, where are the other humans, where are the traffic lights. Yeah, all these distinctions you are doing based on images, isn't it? So all these things you need to do. So these are some of the tasks which people are able to do. The link is there in the slide. Okay, and some really cool application is basically this is a data set. Somebody, his name is Andrew. I really love him because he comes up with really beautiful blogs. So you can go to his blog, by image search. What he has done is he's really created a data set of people with mask and without mask. Now what you can do, you can use the data set and train a model. Like I said, what does a machine learning model need? It just needs output. It needs meaning. What will be the output? Which will be the answer of your model? So answer will be given an image if a person is wearing mask or not, and such a system can be deployed on probably a grocery store. Unless you're wearing a mask, the gate would not open. Yeah, so like that. So that is the output. So given an image, identify if a person is wearing a mask or not. And what is the input? Just the image. Yeah. So what you can do, you can train the model by giving it probably thousands of images of people wearing masks. And look at the beauty here. Look at the variability. There are gender. There are different people in different angles, different age group. And all these things, the only common thing is mask. And that is what the model will learn. So right side, you have no mask. Again, you give these images to the model. Now the model has learned what is the representation of somebody wearing a mask and what is the representation of somebody not wearing a mask. So next time you walk in, if such a model is deployed, it takes your photograph and just take that photograph, run it through the machine learning model, and it tells the system if person is wearing mask or not with certain probability. Yeah, that's it. I think now we can take a minute break. So just try to assimilate whatever I have said about what AI is. How is it different from machine learning, or how it is similar to machine learning and deep learning? How data science come into play? How AI is playing an important role in your lives? How AI is making strides for humanity by taking it forward, whether it is for the development of driverless cars or making robots that can learn by themselves, things by themselves. It can also be that that the machine learning and deep learning strategies are different from the conventional rule-based. Yeah, I'll give you 2 minutes and then I'll start with the applications. I think it should be over in another 10 minutes.
Yeah, hi Samir, is there an issue?
Sorry?
Uh, yeah, okay, we will get you back your presentation.
Uh, Sorry, sir.
Actually,
Sorry.
currently you are visible
Uh,
to the screen. Okay, sure.
no, that's fine. You can see my full face for some time.
Okay, okay, thank you.
No, no problem. Okay, here's the presentation. Can you see the presentation now again? Can you see it?
Yes, it is visible.
Oh, good. Okay, let's quickly jump ahead and try to talk about application to manufacturing industries. Now, some of you may have questions from different industries. I'll try to answer them, but please be mindful of which a domain I work on. So we develop system at photo gauge. We develop systems which can be used for manufacturing industry. Whether there is a gear manufacturer who is interested in finding out if a given gear is defective or not automatically, or whether there is an engine assembly, where is a car manufacturer who is interested in finding out, given an image of an assembly of an engine, can we say something about the fidelity of the assembly? For example, are there missing parts, or are the parts being fitted based on the bill of material, the BOM? Yeah. So, or in some sense, we are also working for industries. So basically, all these industries are making something. Right? They are manufacturing industry. So let me just go ahead first. So like I said, now we know, at least we have some good idea of what AI is and where is it being used. It looks like it is new electricity and it is being used at everywhere. And I had also made a point, which I would like to reiterate again, that for all of these areas, really, you don't have to be expert in the field. If you know AI, I don't know if it is fortunate or unfortunate, but this is really has become a norm of the entire application that are being developed using deep learning. That you don't have to be don't have to know the gene theory just to come up with a new genome, or you don't have to know anything about botany. And you can still develop something, some genes which can help you, say, circumvent some kind of worms. So all these things people are doing because now they have data. There is enormous amount of data. You can use the data, train your own AI models, and really deploy it and make them do work. Because, like I said, the machine learning model is the one who is learning the rules. You don't have to know the rules. Okay, so one such example is in the material behavior study. Now, suppose you are a mechanical engineer. In fact, you can be an electrical engineer as well, where you are developing a new kind of material which would be subjected to excruciatingly high temperature, or which would be subjected to enormous loads, and you would like to understand if this material, how would this material behave, or this material, you're trying to build the lightest material that are out there, because and then it would, by still maintaining the kind of strength the material would possess. All these questions are being answered by the material behavioral study. Okay, one such technique is called digital image correlation, and this is something that I worked on during my PhD. So you can see in these videos, that is, by the way, my hand. So you can see I'm just trying to give you an example of, if you squeeze a ball, really you are tracking the deformations that the ball undergoes. Now, once you know the deformations, you can compute strains, and then through, say, something called inverse techniques, such as virtual fields method or a finite element method, where you can, given this data, you can comment or estimate material properties. For example, if this is a linear elastic material, you are interested in the Poisson's ratio and the Young's modulus of this material, and this material would be characterized fully. But they may be very complicated rubbers. So, for example, you are doing designing for tires. Now, the tires really, to me, are the most underrated design, most underrated part in the whole world, because tire design is so intricate and important that we tend to overlook how much R&D would be going into it. For example, do you know the entire plane? It lands on its landing gear tire, isn't it? So the tons of weight at that kind of velocity, it just takes. You have seen supercars, you have seen F1 cars, where the tire engineering is one of the most important element of the entire. So if you have to develop such rubber materials or such reinforced rubber material, then you need to do some behavioral study. Till this point, what people do, people like me, we do PhD, we spend 5-6 years just to study and learn techniques of how to characterize material, and then we collect data, and then based on the data, we comment on the material. But things have started to change now. Like I said, for example, look at this video. So to do material behavior, we do something called different tests. So this is something called uniaxial tension test, where we just break it. You can see it, right? And then based on this, the deformation that you're seeing on the screen, we compute these stresses and strains. You can see that on the right middle, somewhere in the middle, there was a nucleus that started, there was a notch that gets started and propagated throughout the width. And based on this behavior, we take these results, we take them through the inverse technique that I told you, and we compute the material properties of such material. One more example is, look at rubber. Look at the kind of deformation it is going through. Just huge. So sometimes if you are taking a steel specimen, you are breaking it, there the strain would be somewhere 2 times. So meaning it can actually elongate to the 50% of its length. It can, or the length may get doubled over sometime. But look at here, it just goes 4 times. So there again, the technology remains the same. We take the displacement data, we compute strains, and then from strains we actually compute the material behavior of such rubbers. These are viscoplastic rubbers. But now, sadly, I'm going to be out of the job very, very soon, because there are people who have started to use machine learning to do that now. So we use, to get to displacement, we do these experiments. For each experiment image, there is a painstakingly long process of collecting the images, running the images through various algorithms, and then getting the displacement, then use those displacement to compute strains. Even though I said this is a two-step process, but really it has some microprocess in between, which makes it painstakingly long. Until this point, it felt like that was worth doing the PhD, to be honest. But look at what is happening here. What people are doing. On the top is DIC, conventional DIC. Okay? Given an image and a deformed image, really, as you're deforming, you collect the images. There are a set of parameters that you choose. Now, these set of parameters, these come with, you get a hang of them with continuous exposure to the literature. So this is subjective to your experience. So we do so many experiments, and we tend to get to select these parameters based on our own experience, and out come the output on the right hand side, which is really the displacements. But look at what deep learning is doing. You don't have to select any of the parameters right now, and it will still give you results which are comparable, if not better, in the conventional technique. That is a giant leap in my sense, because look where deep learning is coming from. It was trying to identify if in a photo there is a cat or a dog, but look where it has penetrated into now. It has started to make its space into material study. The experiment that we used to do, the algorithm that we used to run, are not going to look the same in this decade, I feel. And that's why, ladies and gentlemen, it is so important for us to learn this skill, or at least get a basic hang of the skill. For example, look at these 2 results. They have shown the results for at 2 different instances during the test. You can see the images number. Image number is basically as you are deforming, like you had seen my video where I was sort of crushing the ball. We are collecting frames, and then as you accumulate more and more frames, basically you are saying that you are into the deformation cycle at the late point where it's about to break. Okay, that was one field. But then there is something called continuum material mechanics. This field actually caters to this overall idea of material behavior. They talk about the constitutive models. I'm sure if some of you are mechanical engineers, you would be able to appreciate it well, but that's fine. But even if you're not, all I'm trying to say is, imagine you're trying to develop a new material for welding. Now, welding is something that each one of us would have done in our undergraduate degree first year, or you would have seen people doing welding outside in the shop. Now the thing is that suppose you're trying to develop a new material there. What was the welding material, the welding rods, for example. Now what you're doing is you have data. You have conducted some experiments. And based on the experiments, for example, these are the parameters that you had input. So welding speed, wire feed rate, arc voltage, and nozzle to plate distance. Suppose these are the parameters that you have. And you are really trying to measure the response of such system. You are saying you are measuring the height and width of the accumulated weld there. Yeah. Now the thing is that earlier, like I said before, what a researcher would do really is take this data and try to decipher what the information is contained in the data based on his or her own experience of the field. But now, what they did was they used a deep learning model, a neural network, and here given a new welding speed, wire feed rate, arc voltage, and say this other 4 parameter nozzle to plate distance, they were able to find out what is the height and width. And this would assist them into identifying what the material behavior is. Another example is again, if a microstructure, if some of you have worked in microstructure, if a microstructure is dendritic or non-dendritic. So again, there they use classification. So again, my point of all this is to imbibe a sense that this class to cat the dog to cat classification has far-reaching implications into the mechanical field. That classification example can be used as the backbone to develop any other system where you're trying to understand, like I said before, given 2 photographs, if the 2 photographs are different, you are trying to understand what is the underlying pattern and what is the underlying representation. And thereby, given a new photograph, you can say if this particular microstructure belongs to class A or class B. Again, this is something called shale modulus. I think I'll skip here. Yeah. So that part is material behavior, computing stress and strains, computing displacements. Now, the thing also is there is something called optical character recognition, which is OCR. Now, how is it used in mechanical industry? For example, our tire manufacturer. They are interested in noting down the serial numbers that are there on the tire. And this is a real example. Again, this is property of photo gauge. Given the non-disclosure agreement that we have with our clients, sadly, I was not able to show you because I didn't know that it was being streamed on YouTube, or else I would have shown you many more examples from my own work, my own company. But this is some of the examples where given the tires coming in from the field, the manufacturer was interested in getting the serial number on these tires. And why is it so important? Because suppose you are getting thousands of these tires, a manual labor doing it or an army of people doing it, you still have a problem that they may not be as accurate as a machine learning model, because humans, we tend to fatigue a lot when we do monotonous or something repetitive. Yeah. So this is OCR. Again, this is, for example, another example from the manufacturing field where given components, that was tire, you are interested in the serial numbers, but given components, suppose you are interested in extracting the serial numbers which are embossed on the part, that also can be done through OCR. Again, the defect detection, like I said, given these photographs, now this is how the model was trained. If you can see, this is again property of photo gauge. So I thought I'll just show you. So on the left hand side is something that you see a model would see. So to the model we give, okay, this is how a defective representation look like. This is a non-defective or a pristine part looks like, and the model learns. So next time when once the model is trained, once the machine learning model is trained, when you supply a new image, it knows what is defective, what is not, and it tags a particular gear defective or not based on that. Yeah. And finally, like I said, you are trying to understand an assembly. Okay, what are the different parts there are assembly, and if there are parts that are missing in the assembly. At this point of time, I'd like to conclude the applications and applications of deep learning and machine learning to the manufacturing industry. We have seen that really you don't have to be expert of the field. If you have certain idea based on your experience, you can use machine learning either to replace what you are trying to do or to assist you into making better decisions, whether it is defect detection, if a part is defective or not, whether it is material characterization, whether a particular material adheres to the rules and the kind of condition it would be subjected to when it will be put in use. It can also be used to, say, do some sort of structural integrity if a particular part has components as per design. To summarize, this is what AI is, my dear friends. AI is, like people say, and it has been often portrayed in the media, they paint a very different picture. It is something to be excited for, something to get excited for, something to get intrigued with. So AI is something that you guys should try your hands on. There are so many areas that you can bring AI in. Like I said, it is more general tool. If you understand the problem by yourself, you can apply AI to your field. Like I given you example, from a plethora of fields, whether it is driverless cars, whether it is computer science, whether it is mechanical material behavior modeling, whether it is defect detection or structural integrity. All these areas, they are mutually exclusive, but they have a common thread of using AI. Now, some of you would be getting bogged down by the information that I throw at you. Absolutely fine. Don't worry about the information. I have started to dabble into machine learning, and I have a long way to go. So it is never late. I'm in my mid-30s, and this is the time that I've started to learn AI. So age is no bar. You can start to learn AI anytime and anywhere you like. All you need is enthusiasm. So these are some of the resources that I have followed for this particular talk, and I follow in general. So if you are new into machine learning, so it is better you get started with these keywords that you see on the screen. You can note down, or you can take a screenshot. And these are the things that you should definitely do, so that you can actually embark on this beautiful journey of AI. And I really look forward that our path will cross soon. So back to you, Mr. Organizer. I think I'm done. I'm open for question and answers. I think I stopped sharing my screen.
Yeah, hi Samir, thanks for covering the so many topics. So I just ask you some question from the audience or some registered participants. So
Okay.
one of participants, yeah, thank you. So one of participants asking the question related to the current scenario COVID-19. He asked that the importance of artificial intelligence or ML in present COVID situation. And he also had one more thing. Can artificial intelligence boost national economic in present scenario of health and we can say financial crisis?
Okay.
Yeah.
Okay, if I got the question correctly, let me just rephrase it. I think the poster has thought about me very well. I'm not a member of parliament or the prime minister of this country, but I'll try to answer as much as I can. So the first question is basically how AI is changing the COVID research. That's the first question. If I'm correct, the second question is, can AI help boost the economy of this country? And then the last one is, sorry, what was the question? The last?
Nah, it was correct, but there are only two questions.
There are only two questions. Okay.
Including health issue also.
Okay, including health issues.
Yeah.
So like I said, I think that question was posed before I presented, but now after the presentation, it should be clear that really don't have to have knowledge. It's just that you need. I would not say not have back-to-back knowledge. I take it with the pinch of salt. But the idea there is you have to start thinking about it. So suppose in the COVID research, right now, what is the main problem that the researchers are facing? It's not what are the kind of medicine that are there. It's not about mapping the genome of COVID, because that is being done and that takes time. That takes time naturally. You can't change. So where machine learning can help is basically given the data on probably the genome structure, given the data on the efficacy of different medicines, given the data on different trials. Machine learning can summarize and probably bring it more insights. It is not a magical tool. It cannot go and solve problems that a doctor is facing. It can't go and generate its own genome structures of the COVID strain. But really, so one point I would like to, for all of us to understand is really, machine learning is not a magical tool. It is still as intelligent as the data. It is still as intelligent as the problem statement, people who have defined it. Yeah, it may help us gain insights. It may bring out something beautifully abstract, which humans would never able to do. But again, you have to define the problem. So for COVID, if you have a way to collect the data, if you have a way to have an ensemble of the data and what is the response you're looking for, then you can start to use machine learning. And people are starting to use machine learning. There's something called Kaggle. Kaggle is a website that all of you should go to. Kaggle hosts various competitions throughout the world. And one such example was on the COVID research, and probably the results were out in May. So you should look for that. That's the first question. And second, how it can disrupt. So when I say disrupt, not in a negative way, but disrupt is also assisting the economy. Is again, look at all 40 to 50 odd participants that are there and people who are watching from the screens. The idea there is you have to come up with ideas. Until unless how does economy work? It is demand and supply. Until unless you do something at your end, you can't make big changes, my dear friends, but you can make small changes in a big way. Go around you, try to see which area do you work on. I work on material model behavior. Now our company has over 22 employees, so we are providing jobs. We are creating jobs. Not only jobs, they are high skilled jobs. We are not asking somebody to do repetitive jobs. So that's how you can actually contribute to the economy. So to summarize both the questions, I think the COVID, it can really help, but to an extent where you as a researcher can define what the problem you want machine learning to solve. And the second, definitely it can assist the economy, and it has been assisting economy everywhere by making systems which are efficient, where somebody doesn't have to do things repetitively. But that again, the onus is on you, my dear friend. You have to see around you what are the problems you can face. Nowadays, there are things you can sit back home. COVID has also, there is always flip side of a calamity or a disaster. I'm an optimistic person, so I believe every one of you has gotten a chance now. You're sitting at home. You can basically learn more and more about AI, and then not only that, hash out, brainstorm, try to learn and apply. Application always. I always believe, and I always ask my younger brothers. Some of them are here, my close family members. I always tell them that always try to learn while doing. Don't try to learn and do as two mutually exclusive problems. They are intertwined, my dear friends. Back to you, organizer.
Yeah.
I hope I'm not confused. I hope I gave a clear answer.
So I think the one who asked this question understands you are explaining very well. So I have one more question. I just merged two questions in it. Can I?
Go ahead, sir.
Yeah. Thank you. So one of our participants, Dr. Bharat Bhushan Jain, he asked that where we should start if we are new. It is a one. And another one is participant asked in prior question that how to get hands-on artificial intelligence or AML, and how to get a productive internship of the same.
Okay, beautiful. Both these questions, like you said, they are interconnected. So if you are getting worried, and in fact, you're getting bogged down by all the resources that are out there, don't have to do this. On my screen, I think this screen, if you can take presentation, you can start very, very slow. There is no shortcut in this world. There are no shortcuts. So what you have to do is you have to follow a systematic plan. First, learn about machine learning and basic technique. They may not be as cool as the deep learning application but please try to learn from the basics. So get a book. I have noted down a book in the presentation, this from O'Reilly, and this book actually takes you very basic knowledge of machine learning, what machine learning is, different from mathematics, right? It takes you, and then 10th chapter or somewhere, you start to go into deep learning. The 10th chapter you're learning. So don't go to, I suggest that please don't go to online. Okay? I suggest you take a book, code, sit in front of your machine, start from the scratch. Okay, to start from scratch, and then you build on top of it. Yeah. So the thing is that start doing by one book, or if you have already taken a subscription of an online course, please stick to that. Just one thing at a time. Yeah. Take one, and then go very, very, very slow.
Yeah, thank you. I think now I'm asking you the last question. If it is
Sure.
okay?
No problem.
Yeah.
I'm okay with even 2-3 more questions. Okay.
Yeah, it is. It is. We can say something specific like that. There's one of the present participant asking that why in gaming the artificial intelligence is important. And I also add one thing in that.
Yeah, sorry, I didn't catch that. You may have to repeat that. I'm really sorry.
Yeah, sorry. Now I am audible to you.
Yeah, you are. You said gaming, is it?
Yeah.
Okay. Can you please repeat the question?
Yeah, someone asked that what is gaming is important in artificial intelligence. That is the one part of it. And I had just another question indeed. That someone asked that how we can choose an algorithm to solve a particular business problem.
Okay.
Yeah.
I think these are two slightly different questions.
Sorry for that.
Let me give it a shot. Give it a stab. So the first question is why gaming is important, because gaming, if you look at now you may also ask a question, why NASA research is important, why F1 cars are important, because the engineering acumen is tested to its limit, and whatever things are developed there, so ABS, the automatic braking system that you see, and several other automatic techniques have come and became part of the general production. Likewise, for the gaming, NVIDIA actually started by giving gaming graphical cards, and now NVIDIA rules the world in terms of all the GPUs that it has. So gaming is important in two aspects. One is it actually drives a fundamental research forward. That's what I feel that I believe in my view. The second, really, it is a simulated tool. So you don't have to kill somebody to make the model learn. You got my point. If you are playing a Call of Duty or in any other game, suppose Dota or Counter-Strike, you really don't have to kill the participant, but you can actually simulate it and do it over and over again. So the idea is, because it gives you that kind of flexibility, because gaming gives you that kind of flexibility, you can try out of the frame, out of the box ideas and really complicated neural structures to get to that problem. And if you are winning on those problems, like you saw on AlphaGo, then came AlphaZero. But how was it helpful? It was helpful because remember the video I shown you where an AI was, it actually learned how to walk itself, doing motor function that humans have evolved to do. So that's how you use it. So idea is you first develop the gaming, because gaming gives you a nice simulation of the real world. You can kill people. You can, suppose you have a driverless car. You can do all sorts of things. And then slowly, the developed techniques you can start to bring into the mainstream, like we do for NASA research, like we do for aerospace research, we do for F1 car research. That all these things, whatever we learn, slowly, we try to incorporate that in the real field. That's why it is important. Now, the second question is really business use case. What is the business use case here? See, the problem here is not to use machine learning. There are so many areas people can use. In fact, Google has something called AutoML, where you can define a problem and it trains a model for you. It's not a problem. The real challenge here is to define the problem and what you're looking for. How will you evaluate the result? Those are the real problems. So when you use a business use case, you have to define what is the use case, and then what is your response? How do you define a use case as a fail or a use case as a pass? How do you define that? So this is again onto the user. It is not about using algorithms. Now teenagers, they have started to use machine learning because Everything is open source. Anybody can use it. So the real acumen, the real expertise is being put to test. And the experts, now they have started to think, how do you incorporate, how do you define the problems that the teenagers can't? How do you define evaluation criteria that the novice users can't? So the business case is really on the users. Yeah.
Thank you, Samir. Thank you, Samir, for answering that wonderful explanation. But
no problem.
so I just request you. So sorry, we are having interruption in that. Who is? I just leave it out. Yeah. Okay, sorry, Samir. So I just want to request you that you just say a message to our audience, or we can say participants, that if he is going to begin a new era of this, we can say artificial intelligence and ML, then which footstep he can follow consistently? Just a short message for that.
Okay, no problem. So the key idea is now to this session. I am no expert. There are so many experts. I would say I am a novice. I have just started to dabble into artificial intelligence. By no means I am an expert. But the thing is that I have this urge and enthusiasm to learn. I am taking AI open-minded. So if you are a new beginner, you are a new learner, and you are seeing so many. You're planning to pick a best way forward. It's something like trying to find a needle in a haystack, because there are so many options right now. So what you have to do, always start from the book, from books, I believe. So what you can do is there are machine learning books, like the basic machine learning books with Python. Python is the language right now. Python is going to be the lingua franca of machine learning. So what you can do is you start with Python. So there are books which actually teaches you machine learning with Python. Start from there. Finish one book at a time. Don't get swayed by anything else that you see. Don't get distracted by everything that other people do, the cool research, the experts. Don't worry about it. Take one step at a time. This is my New Year resolution, that in 2020, by the end of 2020, I would like to do certain things in machine learning. So likewise, like for example, I would like to write the TensorFlow developer certificate for myself. So likewise, you can set some small goals, because learning is not the destination. It is the process. It is the journey. You have to continuously learn. So if you're a new beginner, start with the most basic book that teaches you machine learning with Python. After that, once you are done with the book, just do all the exercises. Do everything open-mindedly. Once you are done with that, then follow that up with the deep learning with Python book. Once you are done by that, then you start to go and look for some online lectures. There are Coursera specialization, but don't go there before you finish these books, because these books will give you a bird's eye view. In some sense, it will also give you mathematical background. So then you basically go to Coursera, there are Udemy, Udacity, and there are so many other wonderful resources. I'm not undermining them, but my point is, given I have seen the kind of question and answers are there, I believe that you should start from a book, machine learning with Python book, and deep learning with Python book. Then you start to take some online specialization, and that's it. Once you are done with one project, you feel good, then you can start to go to a little advanced side like fast AI, and that's about it. This is the journey. Like I said, please don't treat it as the destination. AI is a journey in itself.
Yeah, thank you, Samir. I think it was a very great session with you. So many our participants on a YouTube, or we can say on the Google Meet, are commenting very nice related to this session. They are very nicely say it was super session, very useful, great sir. Thank you, Samir sir, and lots of things out there.
So much love. I don't need lunch today. I've eaten so much love.
So I also especially thanks from the family of EC Banswara. Now I feel that you are also become a member of our college, because you.
Yeah, the second home. Yeah.
Yeah, in the last couple of months, you also visit our college with your valuable times and valuable knowledge with us. And today you are also explaining mind-blowingly all the topics for the beginners. You also covered all from beginning to the, we can say, the broad level of our like kind of artificial intelligence, or we can say ML techniques and application, how ML are make easier to computer vision and application of manufacturing industries. You also explain your PhD work. Also, you are explain how what is a deep learning and what is the practical of it, and you also explain material behavior, which is your current I can say work in your current profile. I think so.
Yeah.
So again, I would like to say very thanks to you, and I hope you enjoy our company, and we are also very thankful to you that we have resource person like you in future. If we need, then definitely we again we can say contact to you, and I hope you are ready for that.
No problem, sir. It's always a pleasure. Thank you. It is a pleasure to talk to people like you. Thank you.
Okay, thanks, sir. Thank you.
Okay. Thank you so much, guys. Have a wonderful weekend.
Thanks to all participants. I hope today we are going to end our session. We will share a link of feedback after submitting your feedback form. You will get a certificate related to this webinar, and I hope you learn this session or this whole webinar, and it will change your future, and you can take some step toward your future to get something new in your life. And we hope that in future activities, if you organize, then you will definitely join us, and we try to provide a good guidance and good material to you. And again, thank you very much.
एक चीज मैं बोलना भूल गया अभी टेक्ट्यूब थर्ड के बारे में